Greetings, Dr. Will here. Welcome back to the serialization of What You Don't Know, Successfully Lead a Software Project Without Tech Expertise. Episode 16, Chapter 7, Making the Abstract Real, Code, Test, and Deploy, Part 1.
Finally, somebody's writing code. Building a doghouse differs from building a home or a skyscraper. The doghouse might be built without any plans and without any preparation. Without plans and preparation, even for a doghouse, the builder will probably make a few, or many, unplanned trips to the hardware store and have the extra fun of disassembling and reassembling parts of the structure when they don't exactly fit together. Westheimer's discovery by Frank Westheimer, quote, "A couple of months in the laboratory can frequently save a couple of hours in the library," close quote. If the doghouse builder is doing so for a fixed fee, then the buyer doesn't care too much. The buyer is paying a flat rate, firm fixed price. The buyer would only care if the work is never done. On the other hand, the builder will care, passionately, because the extra cost and time spent on the project will be a risk to their business. If the doghouse builder is being paid time and materials, then it is the buyer's turn to care, passionately, if the work drags on as the costs continue to grow. Implementation, coding. The point of it all, isn't it? Producing a working software system? The code, in fact, is not the point. The point is a working system, a solution to the problem at hand. The customer or end user couldn't care less if there weren't a scrap of code in the entire system. They want the solution, not the code. Programming can seem like a black art to people who are not programmers. The basic process overlaps the detailed design as discussed in the previous chapter. It also overlaps testing, unit testing in particular. Essentially, it is a process of writing the module's code, checking it to see that it's correct, noticing that it in fact is not correct, fixing it, and rechecking it until the programmer is convinced that it is correct. More precisely, the developer first needs to verify that the module is ready to be programmed. One key aspect of readiness is that correctness is understood. If a programmer doesn't know what the module is supposed to do, then it can do anything at all, and probably will. If the module has complex processing logic or data relationships, then it may need some detailed design. Simple modules, the kind given to junior developers in their first real-world job, likely do not need a detailed design. Still, it may be required of the junior developer to have their work and approach checked by a more senior developer. Junior developers need that kind of coaching, but in our "we need it yesterday" approach to development, there's precious little time for it. The program is then written in appropriate programming language. This is a process of creating data types, naming variables, selecting control structures, and organizing the code into groups of statements. The groups of statements are grouped into structures called procedures, functions, classes, packages, and that sort of thing. An entire hierarchy of structures. And all that might sound like gobbledygook. Everything and more needs to be specified down to the finest details, or things can go wrong. Horribly wrong. One thing that may go missing here is error handling, especially with junior developers. Let's say that the algorithm, the program, that is being written involves dividing one number d by another number t, computing v equals d divided by t. Recalling high school algebra, what happens if t equals 0? Well, d divided by 0 is undefined. Computers in particular hate it when a program does this. They hate it so badly that they just flat refuse to go a step further. If this exceptional condition is not handled by the aptly named exception handler, then the entire program will crash. People hate that. There's a lot of hate to be avoided in programming. The computer will throw a divide by 0 exception, and the exception handler will catch the exception and handle it in any of several different ways. Processing can then continue calmly and peacefully now that the offending exception has been successfully handled. By the way, there are lots of things like this in computation. Different programming languages may cause different various exceptions. Because software crashing is generally thought to be a bad thing, error handling should be included in every module, and it should be done well, mindfully. The development team should have standards, documented standards, that describe the canonical method for handling exceptions throughout the system. Notice that the typical error in software development, especially among inexperienced developers, is to just program the happy path, the land of make-believe where all their assumptions about the quality of the data being used hold, and everything works correctly, as expected. That is, t never equals 0. They don't even consider that it might, ever. Also notice that the happy path is easy and straightforward. a land of tea and dumplings, where I write a few lines of code and bam, it's Miller time. This is usually where optimistic estimates of cost and schedule come from. 90% of the time and budget is spent on the first 90% of the code. The remaining 10% of the code consumes the other 90% of the time and budget. By the way, 95% of all statistics are made up. Programming must include the team members reviewing each other's detailed designs and code. That means that the detailed designs, if they are to be reviewed, must exist. It also means that there are others writing code. The solitary code slinger is an existential risk to a development project. Unless the project is small and inconsequential, it will need more than one lonely, introverted developer. Even a spreadsheet should have quality checks. One study concluded that 88% of spreadsheets have errors. This is a study in What We Know About Spreadsheet Errors by Raymond Pankow in the Journal of Organizational and End-User Computing. These are spreadsheets that are used to run businesses, some of them big businesses. From the article, 7 Biggest Excel Mistakes of All Time, quote, drug maker AstraZeneca was in the process of releasing its financial guidance reports at the end of 2011, part of which involved a, quote, routine consensus collection process, close quote, and an Excel template. The template, which included embedded confidential company information, was then sent to analysts along with the rest of the financial guidance package.
That ends Chapter 7, Making the Abstract Real, Code, Test, and Deploy, Part 1. Join us next time for Episode 17, Part 2 of Chapter 7. Remember, you can always cut to the chase and purchase the book in their preferred format. See the show notes for the link. That's it for me, for you, for now. Be careful out there. Bye.